Good morning. So today for the math lesson, we're going to be looking at probability, but we're looking at a specific type of probability called probability trees. So probability trees are a way of sort of mapping out visually all the different options when it comes to the chances of something happening. So let's take a look at a simple example. What is the probability of flipping a coin and getting heads both times? So here's flip number one. I'm using a loonie here. There's heads, tails. Flip two, heads, tails. So what is the probability of getting heads both times? Well, there's my heads both times right there. But how many actual combinations do I have? So let's take a look at the combinations. So I can get tails and heads. So there's one. Tails and tails. That's two combinations. And then I can also get heads and tails and heads and heads. That's two more combinations. So in total, if I count these lines, they each represent a combination. I have four possible ways of getting different combinations of heads and tails. And I'm looking at the probability of getting heads both times. So here's my probability of getting heads both times right here. So let's take a look at a different way of mapping that out. So the lines aren't all crisscrossy like this. So this is called a probability tree. I got my first flip here, and then I've written down my second flip, and I've drawn it out twice to represent the possible combination. So you can see I've got the same number of lines, but I've just made two copies basically of the heads tails for the second flip. So I've got tails tails, tails heads, heads tails, heads heads. So there are four possible outcomes, four combinations. Flipping heads two times is one possible outcome, right? So it's right here. It's one possible outcome. So the probability of flipping heads twice on two flips is 1 out of 4 possible outcomes, right? So I've got my other outcomes. 1, whoops, that's terrible. 2, it's hard to draw with this mouse. 3, and then the black one is 4 is the one I'm looking for. So there's 4 possible combinations. So we're going to take a look at another problem using the same strategy, all right? So here's a little mouse, and he's got to get to the cheese. He's got to go through this maze. Every single time he comes to a intersection or a place where there's a choice to go left or right, we're going to flip a coin to see which way he's going to go. All right. So we're going to use a coin to help the mouse through the maze to the cheese. Try to get out of the maze 20 times. We're not going to do that. How many times are we able to get the mouse to the cheese, and what is the probability? So what we're going to do is we're going to take our little mouse here, and we're going to pretend that we're flipping a coin. We can't, I don't have a virtual coin flipper, but we're going to pretend we flip a coin. So let's get here and say he gets tails. Well, if he gets tails, let's say he goes left, all right? So let's go, I'm going to write this here. So tails, whoops, equals left. Heads equals right. Right, so he's going to go, make this a lot smaller here. I got to get rid of this. I'll put this up here. So if he gets tails, he's going to go left. If he gets heads, he goes right. So let's pretend he goes to the first intersection. I flip the coin and I get tails. All right, tails, he has to go left. That means he's going this way. Another intersection. Now he's got to go, I flip the coin again and say I get heads this time. He's got to go right. Another intersection. Say this time he gets tails, he must go left. Whoops. He did not get to the cheese. He's at a dead end. All right, so that particular combination did not get him to the cheese. So let's go the other way. So he gets here. Let's say he got heads. He's got to go right. Let's say he got heads again, which means he's got to go to the right path. And let's say he got heads again, which means he got to go the right path. He's going to go down here. Cheese. All right, so I got the cheese that time. So let's take a look at all the possible combinations and what are the chances of the mouse getting the cheese? What's the likelihood that he's actually going to get fed? This is probably not a good way to treat a mouse, by the way, because he probably starved to death. But let's take a look at how many times the mouse actually gets the cheese if we're using a coin. All right, so I'm going to put this on dual page display here so you can see the next page. All right, so whoops, there we go. So there's our mouse and there's our maze. He gets to the first, so this is the first, whoops, So first, let's say first corner. Here's my first corner. At my first corner, he has to go left or right. He can go left, he can go right, all right? Then, whoops. He's going to go to the second corner. Second decision. Then he's got to go to the third. There's only three, no matter which way he goes, there's only three choices, right? 1, 2, 3, 1, 2, 3, 1, 2, 3, and 1, 2, 3. So there's only three choices. So he gets to the first corner, he can go left, all right? So if he goes left on the first corner, there's left. His second corner, he can go left and right again, right? Left and right again. So there's the left and right chess choices at the second corner. The third corner, you can go left and right again. All right. If he goes left on the third corner, right, left on the third corner, he ends up down here and it's a dead end. If he goes right on the third corner, he's also at a dead end. So neither of these are going to get him to the cheese. If he goes left and then right and then left, he ends up at a dead end. So there's left, right, left. There's nothing there. But if he goes left, right, right, he gets the cheese. So there's the cheese. So there's left, right, right. So there's one possibility for getting the cheese. So let's see what happens if he goes this way, right. So at the first corner here, he can go left and right again, right? So let's go right. Let's say he goes left. And then he's got a decision to make left or right, but both the left and right choices here end up with nothing, right? So both left and right choices don't give him anything, right? So if he goes right, left, left, nothing. Right, left, right, nothing. All right, so that's there. Right, left, left, right, left, right, no cheese. All right, so if he goes right, right, left, he gets nothing. Right, so right, right, left gets him nothing. Right, right, right. There's right, right, and right. He gets the cheese again. So you can see this probability tree has shown us that he has two opportunities. So he has two chances to get the cheese. And how many do we have? Like how many possible outcomes? So two chances out of how many possible outcomes combinations do we have here? Well, let's take a look. 1, 2, 3, 4, 5, 6, 7, 8. So two chances out of 8 to get the cheese. So that means that he probably doesn't have a very good chance of getting the cheese. 2 out of 8 is not a lot of probability. Actually, strangely enough, it's the same probability as our coin trick. Our coin trick was 1 out of 4. 2 out of 8 is the same as 1 out of 4. They're both 25% chance. So interestingly enough, that's the chances of him getting the cheese. So these are called probability trees. We're going to use these a little bit next week as well, but this is probably your last sort of more intense math lesson before the end of the year. So that's probably good news to you. So anyway, so that is our math lesson. Enjoy the rest of your morning.